Cool, thanks everyone. So LendingHome, for people that haven't heard of us, we're a mortgage bank. We're a mortgage bank that's built from the ground up with technology in mind. So unlike most mortgage banks, when you apply for a loan with us, if you want to buy a house, you can actually go to a web form and fill out a form. We don't have a banker that sends you a PDF. You don't have to do any paperwork. It all happens online. And we close your loan really fast and give you a rate that's transparent, clear, which is actually pretty innovative in the mortgage space. And we also, so we're a platform for originating mortgage loans. We allow investors who want to invest in mortgage loans the opportunity to do that. If you think about when you literally give your money to a bank, it just sits in these accounts that bear like really, really low interest, and the bank just turns around and loans it out to people for their mortgages and make 20 to 40 times what you get paid out in interest. So we think that needs to change, and LendingHome is a platform to do that. And we, Looker is really at the heart of everything that we do, because everything that we do depends on data. Every conversation we have with our customers, with teams internally, it all focuses on data, because data, these are facts, right? We have fact-based conversations around the company, and we need very simple ways to communicate with one another about what's going on, to communicate with our investors about what kinds of returns they should expect, and to communicate with our borrowers about where their loan stands in the process and what they should expect from us as their lender. So here's one example of what an investor who's invested money with LendingHome would see. This is a real screenshot from our public-facing investment portal. So when an investor logs in, they can see immediately in real time what kinds of loans we originate at varying down payments, different rates, different loan amounts, different states. And this is an embedded Looker dashboard that took me about 15 minutes to build. I think if we had probably gone through a typical product engineering process, it would have taken maybe 10 times that long conservatively. So this is pretty awesome, and this just kind of scratches the surface of stuff that we use Looker for that's just public facing. Inside the company, we use Looker to drive a lot of our workflow as well. So a mortgage loan is much more complicated than a lot of consumer credit loans because there's a property, it's much more regulated, there's regulations that depend on the state. It's just a whole different deal. And so this is something that our operations teams looks at to basically tell what needs to get done for loans that are closed on a particular day, or that are gonna close on a particular day. And blank is good, right? Blank means there's like nothing to do. But when an ops person sees that a couple loans have popped up, they can just click, drill in, and immediately see what loans have stuff that needs to get done. So these columns are for things like, an appraisal needs to get ordered, flood needs to get ordered, title, insurance, all these sorts of things we have to do early if we're gonna close loans on time, which is big for us. And by the way, so at the heart of Looker, sort of the most amazing thing to me is the LookML engine. You can write little bits of SQL and chain them together and reuse them to do pretty complex things in an easy way. This one query generates a 1,200-line SQL query, and this is a little bit insane, right? You would never ever be able to manage something like this. You wouldn't dream of writing it. You just wouldn't think about this. But Looker makes it possible. We've run this thing. We have about a dozen different looks like this that run our ops group, and we've been doing it that way for about 7 months now. So pretty powerful. So these are all pretty straightforward business problems that we use Looker for. We also try to innovate on the harder data problems that we have. So we care about innovating on credit, right? We want to underwrite borrowers that might not ordinarily be able to get a loan, and we want to do that in a safe, controlled way. So, my job at LendingHome is to essentially do all things data, but my specialty is as a machine learning scientist, right, a data scientist. So when we got started, we knew that we had to do a great job on credit. And so we went out and we bought a bunch of historical mortgage performance data. So back at LendingHome, we've got around 50 million loans and month-by-month payment performance on all those loans that we can use to inform our credit models and our credit decisioning. So this is a hard problem. This is the sort of problem that fixed income guys, hedge fund guys, people work on these with some pretty serious energy. So we'll take any kind of leverage that we can get to make real progress on them. And I just want to highlight kind of how that workflow looks without Looker in places that Looker really makes that process easier. So this is kind of my life pre-Looker. I would get started on a problem. I'd say, okay, I've got to model defaults in mortgage. What factors might matter? I want to look at every factor based on how that factor varies with loans that performed, loans that defaulted. And I would end up writing a lot of kind of gross code like this that was just throwaway code and just exploratory, just exploring data. This stuff does nothing but makes plots. And it's really frustrating, right? Because you don't go to graduate school to write this sort of code. This is not good. So that's life before Looker. This is life after Looker. I just kind of load everything in the database and let Looker go, right? So like if I want to explore how FICO varies with loan performance, in a few clicks I've got something like this, right? And it's very clear. So the tall bars are loans that didn't default. The short bars are loans that did default. And each one of those, each pair of them is like a FICO bucket, right? So you see that the two biggest ones are like the borrowers that have between a 600 and a 700 FICO score. So there's a lot of borrowers there. And by the way, like mortgage is a huge, huge market. If you look at those totals on the bottom, that's around $4.5 trillion. Yeah, I always get confused, and I'm really glad that Looker prints the commas because I never deal with numbers that are that big, right? So this is just a subset of the mortgage universe, right? This isn't everything. So it's a really big problem. But what's really like kind of sad about this, right, is that if you just go out and lend based on FICO, you're going to see pretty bad performance for the most part, and that's why banks have tightened credit. If you've got a sub 700 FICO score and you wonder why it's tough to get a loan, this is why it's tough to get a loan, is the banks just look at pretty much just your FICO score and have these hard cutoffs. But if you throw there's kind of a rescue here, right? There's more to the story than FICO. We think we can innovate and build a more predictive scoring engine. And I'll actually show you that we can. So these modern statistical machine learning models are engineered to mathematically figure out what kinds of factors are correlated, but that you might not think are correlated, right? And pull those sorts of things apart and make better predictions. So they're really powerful. The problem is that they can get really, really difficult to interpret. If you don't care about interpreting models, you can just kind of walk away from the rest of this. But for somebody like us at LendingHome, we care about our underwriters actually understanding what our models say about the data. Because we'll never have a fully automated mortgage origination process, right? We'll always have some human in the middle, and when we either ding a loan or promote a loan, we want to say, here's why we think that's a good loan or a bad loan. So yeah, just to kind of give you a flavor for what these models do, they don't just like make up numbers, they learn numbers. So this is a model that this P of X given Y is kind of a thing that people ding this model for. It assumes that all the factors are independent when they're really not dependent. Like the fact that somebody has a job where they have a really, really great salary and a really high credit score, those things are correlated typically. If you say that they're not correlated, you're just like fooling yourself. So to get around that, there's another class of model that says, oh, I don't care about the correlations. I'll just model it with this function, and I'll train some optimizer. It's nice and convex, and you could solve and get okay results, but sometimes people don't like this function, so they switch to like a different class of models. These models try to like draw a hyperplane in however many dimensional space you've got with your features. We have around 100 that go into our model, so I can't visualize anything over 3 dimensions, and that's even hard for me, so that's tough. It just gets real gnarly real fast. And so I kind of, and this is just like the tip of the iceberg, right? If you go to grad school in computer science and you study machine learning, you get hit with the book of about a couple dozen of these, a couple dozen different families of models. So I kind of had this aha moment where I figured, well, we used Looker to explore the data. We can also use Looker to explore the model. So if we just learn one of these models, we run it on a bunch of data and shove that data back into Looker, we can see what the model's learning. So let me just give you a reminder. This is the FICO slide we looked at before, where a lot of stuff, we sort of got the good loans and bad loans jumbled together in that 600 to 700 FICO bucket. Train the model, run it, do all the stuff that I've been talking about, push those results back out, and we see this. So the light bars are loans that the model takes. And an important thing here is that all the light bars are greater than 1. So the number that you're seeing is like the return on investment. If I give you $1, how many dollars do you give me back? So greater than 1 is good. You want to make money. You don't want to lose money. And what's really kind of funny, right, is that we've figured out how to cherry pick the loans in the 600 to 700 FICO bucket and get good returns. And at the same time reject the loans that actually don't perform, where you lose money. And just by the way, remember that the $1 trillion number, right? So when there's 10% loss on a pool of mortgages, that's catastrophic, right? That's a lot of dollars. So yeah, that's kind of how we use Looker in our data science flow. So yeah, heavier data problem, but still interesting from a Looker perspective. And I think it's pretty cool that we can use the same tool. I don't know of any other tool in the company that we can use on our hardest problems and our easiest problems, right? All the way from like just counting stuff that ops needs to get done to close a loan tomorrow, right? All the way to this. So yeah, that's LendingHome. That's our data problem. Those are our data problems and how we kind of think about the world and how Looker helps us win. Yeah. That's it.